Okay, let's look at some questions about how to design buildings that will be earthquake resistant. So first question then becomes, well, what are the ways that buildings fail in earthquakes? How do they fall down? A real classic mode of failure of buildings is this kind of behavior that you see. This is actually a building destroyed by the Loma Prieta earthquake, the World Series earthquake, in 1989, earthquake on the San Andreas Fault near San Jose. So this is a building in the Marina District, and it had a bottom story to it which did not have very much resistance to shear. In other words, as the ground would move horizontally, it would shear the building, and this building did not have good resistance to shear, therefore the bottom part of the building was significantly damaged. And some buildings literally fell down completely because their bottom story had little or no shear resistance. So what I have here is a building, a frame, that's made out of tongue depressors held together with some bolts to sort of demonstrate the framing of a building. As this is built with just horizontal and vertical members, it has no shear resistance. So if an earthquake comes along and we shake this thing horizontally, then the building folds up. So its stories have no shear resistance. Let's look at some options for how we can put shear resistance into buildings, put some shear strength into buildings. One way to do this is to put in what are referred to as shear walls. And so we can model that in this case with just an index card. So take the index card, fasten it on its corners to the tongue depressors. Now the index card is actually producing shear resistance, some shear strength in that bottom story. So now earthquake comes along, bottom story does great, it holds together just fine. Top two stories, still, with just vertical and horizontal members, don't have good shear resistance. Another option would be to put in cross members. So we can just take a strip of paper here. These strips have no compressional strength. I can take the ends and push them together, and of course they have no strength in that direction at all. But they do have some tensile strength. I can pull on the ends of them. And of course, if I pulled really hard, I could rip the paper, but it's got much more strength in tension than it does in compression. So now, take the strips of paper, place them on here. A classic way to do this is to make an X. So we'll fasten that one down there. Fasten this one up here. If you have only one of these cross members in here, then you only have shear strength in one direction but not the other direction. So you need to make an X here. And if you drive by construction sites where big office buildings are put together and you see them in the stage where only the framing is visible, you'll often see this kind of configuration. So now we've got a good shear wall, we've got shear strength in the bottom story, we've got cross members here to produce shear strength in the second story. Now earthquake comes along, bottom two stories are shear resistant, they can withstand horizontal motion of the building. We only got one story to go here, and you can do this with string actually. This is the perfect material which has absolutely no compressive strength whatsoever, but good tensile strength. Pull it apart and it resists breaking. So you can take on the bottom part where the nuts that hold the tongue depressors together are projecting, you can hook the string around here and do something like this. Hook it around there. Get some shear resistance in one direction. And then do something like that. Hook it around in the other direction. Again, you're just making an X so that you're producing shear strength in two different directions. And just for fun, I'll show you that you can do this even with a rubber band. So with rubber bands, the trick here is they have to have the same strength. They have to actually be matched rubber bands. You can't have one stronger than the other or it'll torque the building off in one direction. So you take one rubber band, hook it on to one set of bolts producing shear strength in one direction, then a matched rubber band going in the other direction, make an X out of it, and you've got reasonable shear strength then on all 3 stories. So earthquake comes along now, and by putting in a shear wall in the bottom story, cross members in the second story, and another set of cross members, but just with something that has no compressional strength at all, like a rubber band, then you've produced a building with good shear resistance. It can withstand the horizontal shaking due to an earthquake.